Okay, we're getting into the first notes here for chapter 4. Unit 4 is momentum. Pretty easy equation, I guess you'd say, as far as momentum. We say P equals m times v. Okay, P is your momentum. M is obviously your mass, and then v is your velocity. So it is a vector quantity. In other words, it has direction because velocity has direction. In other words, if your velocity is going to the right, your momentum is to the right. Okay, so we say momentum is a vector quantity because it has a magnitude or an amount and it has a direction. So that's basically what you need to know. It's pretty simple, but here's some the more intricacies you'll run into. I mean, the obvious thing would be something like you've got a bowling ball, weighs 3 kilograms, going this way, going right at 5 meters per second. That momentum obviously is going to be 3 kilograms times 5 meters per second, 15 kilogram meters per second. There's no special unit for momentum. In other words, it's not newtons or something. It's just kilogram meter per second. Now let's say we've got a system. Let's say we've got two things that are going towards each other. So there's this other 4 kilogram ball, a little bigger maybe, going this way at 4 meters per second. So that would be negative, right? It's going left. So now we're talking 4 kilograms times negative 4 meters per second. This is negative 16 kilogram meters per second. So if it says a question in your assignment will say, what's the momentum of the system? The system is like everything, okay? That the system in this case is this. Okay, it's the momentum of this whole system, everything that's in here. So in that case, we're going to say 15 kilogram meter per second plus the negative 16 kilogram meter per second. Obviously, we're talking negative 1 is the momentum of the system. Okay, so you run into that. The other thing you'll run into is change in momentum. So let's say this. Let's say a ball, 2 kilograms going 3 meters per second, hits a wall, bounces off, and it bounces back this way, obviously. Negative 3, sorry. Okay, so it's going this way, it hits the wall, this is supposed to be it hitting the wall. Okay, it bounces back. Okay, what's a change in momentum? We'll say delta P. Well, it's going to be your initial momentum, P, or actually your final momentum, PF, minus your PI, right? Your initial, right? Change is always the final minus the initial. So, in this case, your final momentum was this negative 6, right? Your initial momentum was the 6. Okay, so negative 6 minus 6, the change in momentum is negative 12 kilogram meter per second. Okay, which if you think about it makes sense. It had 6 here, right? And then here it had negative 6. What's the change? From 6 to negative 6, what's the change? Well, it went down by 12. That's all this is saying. Okay, so that will be important going forward, this idea of change in momentum. But for today, it's pretty easy. It pretty much just know momentum is m times v, and it's mass in motion. In other words, if you have a really heavy object moving slowly, it still could have a lot of momentum, right? Or if you have a really small object moving really fast, it still could have a lot of momentum. So momentum is a combination of mass and velocity. It's probably kind of common sense. If you have momentum, that means you're moving along, and it's hard for you to stop because you have a lot of mass going and a lot of velocity. Different than inertia, just as a side note, remember inertia was just mass. Inertia, if something resisted changing motion, was just mass. If you're just sitting there with a lot of mass, you got inertia. If you're sitting there with a lot of mass, you actually have no momentum because your velocity would be 0. Okay, have a good day, guys.